Hey everyone, welcome back to the Java Full Stack Developer series. Today, we're diving into the exciting world of Object-Oriented Programming, or OOP for short. In OOP, we break down our problems into objects. Imagine it like this. Each object is a real-world entity with its own properties and behavior. So let's get started and see how this works in Java. So what is OOP? In object-oriented programming, we analyze the problem by identifying the objects involved. Each object has attributes like characteristics and methods like actions. To solve a problem, we define relationships between objects and let each object handle its own tasks. For example, let's say we are building a program for a zoo. Animals can be our objects. Each animal has attributes like name and age, and methods like eat and sleep. Objects are like living entities with their own behaviors and characteristics. Think of them as the stars of our programming story. Alright, so for OOP, we will learn about the properties of OOP. The first is encapsulation. But before we go it, we will create a class person with a attribute name. And this is the attribute, okay? And because you put the access modifier private before defining the attribute, so the attribute cannot be accessed from the outside of the class. So to access the class, you need to create getter and setter method. Alright, that's called encapsulation. Encapsulation is all about hiding the details and only exposing what's necessary. We achieve this by using access modifier like private, like protected, and public. Okay, public for the getter and setter methods. Alright. And we will create a public method which can be accessed from the outside the class and from the outside the package and the world. You can create a method like get the name, and inside the method you will return the value of the name like this. And you can also change the name. You can also assign a new value for a name by creating a public method like set name, and you put a parameter for this method to assign a new value, and in here you will assign a new value from the parameter name to the name attribute like this. Alright, so you can see here we have two methods that can be accessed from the outside the class. So we can change the attribute name and we can get the value of the attribute name by using these methods, but not access directly the name attribute. Alright. The benefit of using setting is that you can control how to set up to set the new value. For example, you can do this. For the set name, you can check if the name is no, you won't do anything, like this. So return is a breaking, is a break. We have learned in some previous video about the state controlment, right? You using return to break down the something after the return. In this situation, we will ignore the line to set the value for a name by returning here. Alright, so that is some benefits while using the setter. Alright, so let's check this program work. So we create a person object in the main method, and here we create a new person, and we can also set. Now you can try to access the name. You cannot do this, right? But you can use the method set name like this, and here you can set the name J, and you can print the name like this, the name. Now in here you also cannot access the name directly like this, okay, but you can use the method getter that get name to get the name value from the name attribute like this. So let's run it to see what happened. Alright, you can see the name is J. So we use getters and setters to control how the name is accessed and modified it. This keeps the name safe and prevents unintended changes. Okay, encapsulation is like putting your variables in a safe. You decided to guess the key. Okay, so let's move to the second properties, that is inheritance. Okay, inheritance is all about reusing code. It allows one class to inherit the properties and methods of another. To implement inheritance in Java, we use the extend keyword. So let's try another example to see that. And here I will remove the person class, and let's create another. Now you have a class name animal. Animal will have an attribute name and an action or a method eat. For here we will simulate what the animal eats by printing it out to console. Yeah, name plus is eating. We just says the name of the animal is eating like this. And now we will create another class named the dog. So in the real world, dog is an animal, right? Yeah, that's makes sense. The dog is also an animal, so the dog can extend animal like this in programming. This means you are make inheritance from dog to animal. So now the dog can use the attribute name and can use the method eat from the animal, right? But the dog can also have its own method, its own action, like bark. Okay, the dog can bark. print I'm sorry, name says whoop. Whoop, yeah. And now we will jump to the main method and do some symbol for a dog. New dog here, and we can now, as you can see in the dog, we didn't define the name, right? And we also didn't define the method it. But because the dog is extended from the animal, so we can use the attribute name from the animal like this. So because the dog is also an animal, so we can access the name and assign it a value, a body. And we can also call the method eat for dog, because the dog is an animal. And we can also do its own method bark, which is not in an animal. Okay, so now let's run the program to see. Alright, you can see the dog named Buddy is eating. The dog named Buddy says wolf, like a dog. Okay, so yeah, that is a simple inheritance. Yeah, a simple inheritance implementing. Now we will move to the third properties, that is multi-level inheritance. Now, what if we have multi-levels? That's multi-level inheritance. Now we have the dog extend from the animal, right? And what happens if you create another class named Scooby-Doo. Scooby-Doo extend dog. Scooby-Doo is dog, right? It is a character in a cartoon. Scooby-Doo is a specific person in yeah, but it's also a dog. So we can extend the dog to get all the action and all the attribute from the dog. Alright, and for Scooby-Doo, we can Scooby-Doo can bark, right? And what can he do more? Maybe he can speak, because he sometimes speak to his friend, right? Speak, and yeah, we can simulate the action by print it out to the console like this. And Scooby-Doo will have the name, so we don't need to use the attribute name for this. Scooby-Doo is speaking. Alright, you can see we are doing multiple level of inheritance. Yeah, you can see the parent of the parent is animal, and the dog is a parent class, and now the Scooby-Doo is a child class. We have two extend here. So this creates a chain of inheritance. But remember, Java doesn't support multiple inheritance, where a class inherits from two classes. So what does it mean? Two class. You can you can do this. You can do extend the dog and also extend the animal like this. You can do this. Okay, you just only create a chain of inheritance. To do that, to do the multi inheritance. Yeah, please notice this. And now we will go to the abstraction. Yeah, the abstraction means hiding the details and showing only the essential features. It's like driving a car. You don't need to know how the engine works, you just need to know how to drive it. We achieve abstraction in Java using abstract classes and interface. So first is using abstract class. Okay, let's remove all the code and create another sample. Now we have an abstract class. To create an abstract class, you put the abstract keyword before the class keyword like this, and you create a shape class. And in here you create an abstract method like draw like this. You don't need to create the body of the function, the method for an abstract method like this. And in shape you can also create a real method, a non-abstract method like info. So you can print this is a shape. Okay, and now we will create another class. So before we create another class, you need to know you can't create an abstract method from you can create a method from an abstract class like this. Shape equal new shape. You can't do this. Okay, you can't do this directly. Sorry, you need to remove this. So you can do this. You can see that the arrows here. Shape is abstract, cannot be initialized. Okay, so to create a shape, you need to create a superclass which is inherited from the shape. So you create a class named circle, inherits from shape like this, and a class that inherit from an abstract class must be implement the abstract class abstract method. Okay, please remember about the drawer. And for draw method, you can print drawing a circle. Print a circle. Here, the shape class defines the structure, but the circle class provides the implementation to draw. Right? The shaper don't know what the real shape will draw. But when you create a real shape circle, you will implement the method draw to provide how you can draw that shape. In this situation, you draw a circle. So you know how to draw a circle. Okay. So how about the interface? An interface is like a contract. It defines methods that a class must implement. We just do a sample. Interface animal. So the animal will have method like cell. So you create a class. So the class can make cell, right? So you can implement the cell from animal like this. Cell. Draw make the sound by whoop whoop. Okay, and the lion, implement animal, and the lion will make the sound different. Lion can roar, right? I don't know how to write it. Okay, to simulate the sound, and in here you can create animal. Animal is an interface. Okay, you can create an object from the animal directly, but you can define an object with a type as an interface, like this. An animal equal new dog, like this. Okay, and the animal sound. Whoop whoop. And the animal, if in case you knew the lion, like this, it show you roar. Okay, and interface are super useful when you want different classes to follow the same structure but have their own unique behavior. Yeah, the next we will move to polymorphism. Okay, polymorphism allows a single method to behave differently based on the object that causes it. So in the same example we have created here, we are using polymorphism. Right? You can see even the dog or the lion are of type animal, but they call their respective sounds, right? This is polymorphism in action. Same method, different behavior, right? That's right. Same method, sound, but different behavior, even if they are the same animal. This is called polymorphism. So it's very easy, right? I think you can understand more when you create more sample, practice more, and get more understanding. I hope you can do that, and you can understand clearly for polymorphism and something I have show you. Alright, today we explore OOP analyzing problems as objects, encapsulation to keep things secure, inheritance for reusing code, abstraction to focus on essentials, and polymorphism to make methods flexible. I hope this session clarified these concepts for you. In the next video, we'll build on this foundation and dive deeper into more practical applications. And don't forget to like, subscribe, and hit the bell icon to stay updated. See you in the next time.